So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing Leetcode daily problem of the day. The problem is find the number of distinct colors among the balls. And in this problem, we have to given an integer of limit and 2D array of queries with the size of n cross 2. And there are limit is limit plus 1 with the balls of distinct levels. And the range we have to given is 0 to limit. And also each query we have to given x comma y, and the x is mark the ball and y is our color. And after each query we have to need the find the number of distinct colors among the balls, and after that we have to return the result of n, and this result of I denotes the number of distinct colors of ith query. Okay, so now let's look at their problem statement. Then we have to looking their example test cases, how we dry run their example test cases, and then we have to look their coding implementation part. So first we have to given limit plus 1, and this limit plus 1 is our labeled with their L2 limit range. Okay, this is our range, and then initially all balls are uncolored with the given list of their queries, and each query we have to given x comma y, and this x comma y we have their x is our ball and this y is our color. Okay, and now after processing each query, we need to determine the number of distinct colors present in our colored balls. Okay, and now the distinct means this distinct means a distinct color means a color that is assigned to at least one ball, at least one ball. And after, if multiple balls are shared with the same color, it is not counted as a distinct color. Like if let's suppose if a ball color with one, okay, sorry, if the ball 1 is colored with 4, okay, and the ball 2 is colored with 5, so now we can say we have two distinct colors, the two distinct colors. And now you can say if we have a ball 1 and with recolored with 4 and 3, and then distinct colors becomes the distinct colors become 3 comma 5, because this 4 and this 4 is already present, but we have also processed again a 4, so this is not a distinct colors. So now this 5 and 3 is our distinct colors. So I hope you understand the meaning of distinct colors. And now the understanding of their goal, what we have to achieve. We have to achieve each query of x comma y, and this x comma y we have to assign our color with y, and this y and this y to our ball x, and track their distinct colors across all balls. And after each query we have to return the number of distinct colors. Okay, number of distinct colors. So now let's look at their example test case, so that you can understand how we iterate all over the queries and their limits. And so first we have to process with 1 comma 4, and this 1 comma 4 the ball the range is, you can say this 1 to 4. Okay, this 1 to 4 we have their distinct colors is 4, this is our color, and the color present is one time. Okay, like you can say 1 2 3 4 5, this 5 means we have their limit plus 1. Okay, so that's why we have to take 5 balls is our initially all are uncolored. Okay, and after uncolored we have their first ball, this is 1 2 3, and this first ball is our 4. And now we have iterated with 2 comma 5, and this 2 comma 5 we have already processed with like here, this 2 comma 5 we have already processed with 1 to 4, and now we have 2 comma 5. Okay, and this 2 to 5 we have the size of the size of 14,25. Okay, and now this 4 and 5, and that this 5 we have present one time. So now which position? The second position. So now here 5, and now our distinct colors are 4 comma 5. Okay, and now we have also iterate a count, and first initially our count is 0, and then when 4 is present, 4 is occur, then the count is 1, and now this 5 is occur, then we have their count is 2. Okay, and now after track this one, and now we have their 1 comma and 1 comma 3 and 1 comma 3, and this 1 comma 3 where this 1 comma 3 is like, and this 1 to 3 is lies between 2 to 5, like 1 to 3 and 2 to you can say here 5. Okay, and here we have there 1 to 3 and 1 to 3, this 3 comma 5. How 3 comma 5? This one 3 to 5. 1 second. Yeah, this one, but this 5 is occur again, so that's why the count is remains same. We also discuss here, like there is any distinct colors are not present, then we have not count their values. Okay, so now after next iteration we have their 3 comma 4, and this 3 comma 4 we have their 1 2 3, and you can say 3 to 5 and 3 to 4. These are our ranges, and this 3 now our 3 comma 4. Okay, this one 3 comma 4, and this 3 comma 4 we have their third position. Now this one become 4, and this become 4. Now the count is our 3. So our final count is our final count is equal to what we have to get. We have 1 2 2 and 3, and you can say, yeah, 1 2 2 3. Now let's look at their example 2, so that you can understand better way. And here we have 0 1 1 2 2 2 3 4 and 4 5. Okay, and this 0 1 we have like here limit plus 1, so that 1 2 3 4 and 5. Okay, and 0 to 1, 0 to 1 we have to assign 1 2 3 4, and this assign 1, and now 1 to 2 and 1 to 2 we have assigned with 2, and now count is first is 1, then 2, and then again we have there 2, sorry, we have again the 2, but same color, again the count remains same, and again the value of 3 comma 4, 3 assigning with 4, and now count is 3, and again this 4 comma 5, and this 4 to 5 we have to assign with 4 with 5, and now again we have to increase the count. This is 4. So now answer is 1 2 2 3 and 4. So I hope you understand the example test cases, how actually we have to achieve their output, and if the distinct colors is occur, then we have the count is remain same. We have not increment their count, we have to set their previous count. Okay, so now let's look at their constraint. The constraint we have to given 10 to the power 9, and limit can be large as a 10 to the power 9, and this 10 to the power 9 meaning we cannot use an array of size limit plus 1, like limit plus 1, and then if we have to take limit plus 1, this is taking this is increase our size, and this is out of bound of 10 to the power 9, so that's why we cannot take this limit plus 1 array. And now this number of queries with their length of 10 to the power 5, and this can be 10 like number of queries can be 10 to the power 5, so that we can achieve and log n approach and log n solution. And efficient solution is we have to track with their map you can say a map and unordered map, and we have to track with their balls and their colors. And after this we have to maintain a set to track the distinct colors efficiently, and the time complexity of this one is O of n log n, and then space complexity is O of n. Okay, so this is the worst case scenario of this space complexity of O of n. And now let's look at their coding implementation part, so that you can understand how actually we have to iterate all over the queries, and how we achieve this one, like these balls, and then we have to update all balls with their values. Okay, so now first we have to now first we have to take map of int and set of int with their ball color, and this map of color, this map of color is set of balls. Okay, balls with colors. This means like map of color, this map of color with their set of balls, this set of balls with their colors, with their colors. And now the next is map of int comma int with their distinct values, map of ball with its current color, with its current color. And now this vector of int answer is we have to store their results and after each iteration. Okay, and now here first we have their pre-process, like we have to extract ball from a color for a query. Here we have to extract with their ball, and this is our color. And now this ball of C dot insert of B means we have to assign ball B with their color C, like B with their color C. We have already discussed here, like ball with their assigning with their color C, like we have to assign here color. These are our colors, and these are our balls. And now after this we have their ball of color C dot insert of B, and this means we have already discussed, like ball B with their C. Okay, and now on this distinct colors dot count, and this distinct color or dot count means if the ball was previously colored, we have to remove the old, like here we have to remove old color. Okay, here we have to remove old color, and if old color not is equal to C, like if the color is changing, like here we have their, again we have to find their distinct color. If it is changing, then we have to iterate this one. Like what we have to iterate here, we have first we have to remove the ball from the old color set, old color set, and after this we have to remove the color from the map. If here we have to once again we have to remove, here we have to remove the color from a map if no balls remain, no balls remains. And after this we have to store the distinct colors size, like uh, we have already discussed, like here first 1, and then again 2, then 2, then 3, then 4. After all these values we have to store into our answer, and after this we have to update, this is our update condition, update our balls with new color, with new color, and then we have to return our answer. Like at first what we have to do, we have to maintain a mapping color, mapping color, and after mapping color we have their set of their colors with their balls with their colors, and we have to store its current color. And then we have each query, and this is our x comma y, you can say already given here x comma y, and now we have to declare with their ball, and this is our color. And also we have given a 2D. Okay, here 2D array we have already given here, so that's why we have to assign with 2D array form. And now the assign color with C to the ball B, and we have to here B to the set of balls with color C. Okay, and now after all the after all the pre-processing, we have to find there our answer, and the time complexity of this code is each insert, erase, count operations taking in map is O of log n. And after this we have to pre-process with their queries, and here the queries, and this query takes n time, and the total time complexity of this code is O of n log n. And the space complexity of this code is we have their ball color and distinct colors O of n times, because we have to store all these values, and also we have to iterate with their answer, and this answer is also taking O of n time, and the total space complexity of this code is O of n time. This is the worst case scenario. We have to getting a O of n solution, okay, of space complexity. So now the final what like what we have to do, we have basically we have use a map of efficiently track their colors, okay, we have to track, and then we have their set to ensure each color stores uniquely. Then we have to use a set, like if the color is again occur, then we have not store into our set, okay. This is a pre-computation technique, so we have to follow here. And again we have their approach, we have to avoid their large amount of complexity, we have to reduce uh, with their algorithms, like we have to use set and map, okay. So now the complexity is O of n log n, and if it is efficient for n is equal to 10 to the power 5 solution, okay. And I hope you understand the logic and the implementation part, how we actually uh, take this x comma y, and this x comma y we have to check with their queries, and this query is this is first we have to taking their limit plus 1, and after limit plus 1 we have to assign all the colors with their balls, and then we have to count their distinct values. So thank you everyone, thank you so much.